Hello students, I am Professor NAVNEET KAUR, Associate Professor in EC Department, SIRT College, Bhopal. Today I will be taking lecture on subject digital communication. The topic which I will be taking is D1 Digital Carrier System. First we will see what is time division multiplexing. Time division multiplexing is a digital multiplexing technique for combining several low-rate channels into one high-rate channel. Now, here we can see the figure which describes the process of time division multiplexing. In this figure, we can see that there are four signal sources. The signal from each source is sampled. Each sample is transmitted at an interval of Ts, which is sampling interval. When we consider a single source, then in between the two samples of each source, there is a time interval of Ts. Since the duration of the sample is very small as compared to the sampling interval Ts, the space between the two samples is wasted. Now, in this space, the samples of other sources like source 2, 3, and 4 are adjusted. And so the interval Ts, which was initially used to accommodate only one signal, now it is used to accommodate four signals. So here, four signals, or we can say four samples from four sources are transmitted simultaneously by occupying the sampling interval Ts. So this is called time division multiplexing. Now these samples will be received by the receiver side, and the samples of all the four sources will be recovered by their destinations respectively. Here we can see the sharing of the signal is accomplished by dividing available transmission time on a medium among users. There are two types of time division multiplexing: synchronous time division multiplexing and asynchronous time division multiplexing. Synchronous time division multiplexing is the original or most commonly used time division multiplexing. T1 and ISDN telephone lines are common examples of synchronous time division multiplexing. Now here we can see that we have four sources, and here we will describe synchronous time division multiplexing. Each signal is divided into three samples, like first signal is divided into sample A1, A2, A3. Similarly, second signal is divided into B1, B2, B3, and third is from C1, C2, and C3. Now data is taken from each source every T seconds, where T is the sampling interval. Now here, first the sample first will be taken from the first source, which will be A1. Then B1 will be taken from the second source, and then C1 will be taken from the third source. So A1, B1, and C1, they will be accommodated in one frame. Similarly, A2, B2, and C2, which are the second samples from all the three sources, will be adjusted in frame 2. And A3, B3, C3 will be accommodated in frame 3. So here we can see that each frame occupies a time interval of T second. So each time slot duration for each sample of a single source is T by 3 seconds. Three types of popular synchronous TDM systems which we use: T1 multiplexing, ISDN multiplexing, and synchronous optical network. Now, here we will describe T1 digital carrier system. T1 digital carrier system is used to convey multiple signals over telephone lines using wideband coaxial cable. Here we accommodate 24 analog signals which are band limited to 300 Hz to 3400 Hz. Now, each signal is sampled at the rate 8 kHz. Now, each of the TDM signal is analog to digital converted and companded. The resulting digital waveform is transmitted over a coaxial cable. The signal is regenerated by amplifiers called repeaters placed at appropriate intervals. At the destination, the signal is companded, decoded, and demultiplexed, making available 24 original signals. So in this figure, we can see the representation of the T1 digital carrier system. Here we have 24 voice channels, which is used in telephone lines using coaxial cable. Each signal is band limited to approximately 300 Hertz to 4000 Hertz. Now, each signal is pulse code modulated and sampling of each signal is done at the rate of 8000 samples per second. And we use 8 bits per each sample. Now they are combined using time division multiplexing and is transmitted over a channel. Now here we can see, since there are 24 channels and in one frame, one sample is taken from each sample, where each sample is composed of 8 bits. So in one frame, we will have signal from 24 channels, where each channel will be composed of 8 bits. So total bits in one frame will be 24 into 8, which will be 192 bits. So here we can see that each frame is supposed to be made up of 192 bits. But there is one requirement for time division multiplexing system, which is synchronization that must be provided between transmitter and the receiver, so that receivers should identify the sample from each source. Now for synchronization purpose, one additional bit is provided at the beginning of each frame. So one bit will be provided in addition to the 192 bits which is provided for data signal. So total bits will be 193 bits in one frame. Now, to calculate the line speed, which is bits per second, we have 24 channels per frame, where each frame is composed of 8 bits per frame, which will be 192 bits per frame. Now, since there is one additional synchronization bit, so there will be 193 bits per frame. Now, if we want to calculate the line speed, so 24 into 8 plus 1 bit, which will be 193 bits, divided by 125 microseconds, where 125 microsecond is the sampling time TS. TS is given by 1 upon Fs, where Fs is the sampling interval, and sampling interval is 8 kilohertz. So 1 upon 8000, which will be TS, is given by 125 microsecond. Now, if I want to calculate line speed, which is given by bits per second, it will be 193 bits divided by 125 microsecond, which will give 1.544 megabits per seconds. Now, in addition to the synchronization bit, one additional signaling bit or framing bit is also added to provide signaling information, maybe between the two exchanges, between the user and the exchanges, to provide information about the dial tone or the busy tone. Within each superframe, there are 12 consecutively numbered frames. The signaling bits are substituted in frames 6 and 12. It is provided at MSB into frame 6 and LSB into frame 12. Frames 1 to 6 are called A highway, with frame 6 designated as the A channel signaling frame, whereas frames 7 to 12 are called the B highway, with frame 12 designated as the B channel signaling frame. To identify frames 6 and 12, different framing bit sequence is used for the odd and even number frame. The odd frames like 1, 3, 5, etc. have an alternating alternating 1 or 0 pattern. Whereas even frames 2, 4, 6, 8, they have a 0, 0, 1, 1, 0 repetitive pattern. So in this case, the combined framing bit pattern will be 1, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0. Now this is all for today's lecture. Thank you.